welcome to another in our series. We call the Horizon series. We call it that because it looks forward to the future of the livestock sector in Ontario. About a year and a half ago, we decided that we should look at what are the big things coming at the livestock sector. And unbelievably, this is our 14th webinar with another one planned around data use. So clearly there are a lot of things facing the livestock sector, and we want to make sure it remains and grows as a key pillar of Ontario's economy, environment, and food security. Today we have a very interesting topic. I want everybody to visualize driving down the road past farms, and if you must have noticed the amount of wrap that is used on round bales. There is a lot of other plastic used in agriculture and in livestock farming, but that alone is a lot of plastic. If tomorrow single-use plastics use on farms was deemed illegal, that would be a really big problem. And aside from that, there's an environmental problem currently. So today, really glad to have Dr. Erica Pensini with us. Erica is an associate professor in the Department of Engineering at the University of Guelph. Her research focuses mostly on the development of new energy-efficient water treatment technologies that enable water reuse and restoration of polluted aquifers. So that's really cool, but I'm really intrigued by her work on plastic replacements. I got to know Erica somewhat as one of the people in our early career mentorship program, certainly very active, outgoing, keen on connecting with industry. And I was really pleased that through her connection, she has strong support from both Beef Farmers of Ontario and Dairy Farmers of Ontario for the work that she's taking on in this regard. So Erica, over to you. Looking forward to the presentation.
Perfect. Thank you so much for the introduction, Mike. I'll start sharing my screen here. And are you guys able to see this properly? All good? Awesome. Thank you so much. So I guess that Mike gave a very kind introduction for me, and today I'm going to talk to you a little bit about what we've been doing to develop alternatives to bio-based materials. Mike said already, talked a little bit about the environmental costs of this, but before going into more detail, I want to really make sure that it is clear to you what the environmental costs are for plastics. So essentially, making plastics starts from petroleum extraction, and then it's a fractionation into its components to ultimately make monomers for plastics. So when you think about plastics, you don't really have to only think about improper disposal, but you have to think about the fact that you need to extract the oil, and that takes about between refining and extracting, it's about 6.5 barrels of water per barrel of oil. So a lot of that. Then you have to transport it. There can be some spills, not necessarily, but for sure there's a cost with extraction, and then you have to produce the products. So essentially, if you want to make monomers, you have to start from something, say like naphtha, and which is already a petroleum derivative, and then naphtha is fractionated, as I was mentioning, to make monomers, and this occurs through energy intensive processes. You have to heat up your feedstock to 700, 900 degrees in a furnace. So once again, if you use oil to make that energy, then that's even more water. So there's a big environmental cost with associated with the use of plastics. And now not only you use a lot of water, but you also in some instances disrupt the aquifer that is close to your oil formation. So as an example, in techniques such as fracking, you would be fracturing the rock, and then water would start flowing from areas where the aquifer was not attached to the surface. So throughout the lifetime of the well, you will always have what is called produced water, which is water that becomes saline as it runs through the rocks, and then you don't know what to do with it. So it's not necessarily only the cost of the water that you use that you extract the oil with, but also the excess water that gets produced along with the oil for the entire lifetime of wells. And so alternatives to that are, bitumen extraction, and whether you use surface mining or even if you use like steam-assisted gravity drainage, you have a problem with environmental damage, right? And I'm not saying that we should phase out oil in a day, but this is what's behind it. Okay, and I was talking to you already about that, the high cost of pretty much treating the oil to produce these monomers. So the question is, can we continue to produce plastics? Because one of the questions that I get all the time is, what is the cost of the materials you're producing compared to those of plastics? Well, right now we're not really paying the cost of water for what it should be, but we are seeing situations where, which occurred recently, where in the US, as an example, they were debating whether they should produce energy or use the water from Lake Powell for drinking purposes, right? So we're getting into these extreme scenarios, and things aren't going to get any better due to climate change. So the other alternative would just be to take plastics and recycle them. But you all know that agricultural plastics are contain contaminants, and these contaminants make it a bit harder for us to recycle them. And even if it weren't agricultural plastics, overall, recycling of plastics is not as effective as it could be. And China is not accepting our plastics anymore. So we're left with all this waste pretty much. And this is another reason for which we should start thinking about other options. Now, when do these options become a viable economic alternative? Well, when there's an increased cost in oil, whether that is due to political reasons or whether it is due to the fact that we are not having any more water available, and we need to start reusing water and treating it, which adds costs, right? So essentially, as an example, Fords were made with regular plastics, but at some point they started using soy-based foams because the cost of oil was very steep. So there is a little bit of a hope here, because we have the opportunity of changing from regular plastics to these other materials, and there's going to be the right economic scenario to do this at some point. So we've been looking at different options. So we started off with a corn protein. It's called Zane. And the reason for this is that it's because, as you will see in the next slide, it's very versatile. It's very simple to work with. But the problem is that it's very benign, so benign that sometimes the rodents get into it if you just use it in its native form. So we had to do some modifications, and I'll talk to you about that. The other option that we started looking into to really overcome the issue associated with rodent attack was to develop oil-based materials. We made different types, and I will tell you, some of them are spray-on, some of them are prefabricated, but so essentially this is another class of materials, so oil-based as opposed to corn protein-based. So as I was mentioning to you earlier, Zane was a starting point because it's so easy. It's a nice powder. You can dissolve it in water at either high pH or low pH, and then you can neutralize the pH to form these this material, which looks like bubble gum. And if you don't want to, and so it's ideal to make prefabricated materials, but you can also just take the starting fluid, spray it on surfaces, and then solidify. So initially the idea was this exactly: you pretty much create a film, and you solidify it on the spot, whichever surface you want to pretty much impermeabilize. So the idea was that we could use this as mulch. So we made pretty much piles, or like we made model surfaces, and in the lab, everything worked well. We prevented erosion, we prevented runoff. But yeah, as we brought this to the field, we saw that rodents liked it a bit too much. So we said, well, can we still use Zane for some purpose, because it's such a nice material? And we thought of adding in oil, such as tung oil or linseed, to kind of create an off smell and to attract rodents less. And this worked. This worked a little bit better. So as long as you add something that has a smell that isn't so reminiscent of tortilla chips, then you're better off. So we started using Zane to make pots for plants, and so it's quite nice because it can just be made with linseed oil or tung oil. You can include fibers that are natural. You can also customize them with different colors. We use food coloring to make pots with different colors, right? So this would be a good alternative to pots that are using greenhouses. And ideally, you can put them directly into the soil, not remove the seedlings. And this is also good because sometimes that not only waste, but there's also that trauma, so to say, of the plant that gets taken out of one spot and moved into another. So you can make these pots so that they can really be left in the soil. The other problem that we faced, so with Zane, beyond the fact that it didn't really have an off smell, so it was too attractive, was the fact that it wasn't bendy. So what we did was modified Zane and this modification was aimed at making it more hydrophobic and to also make it more flexible upon combination with cutin, which is a component of tomato peels. So after this modification, Zane had a markedly different odor. So we expect that it would be a better candidate. And the fact that we were combining cutin from tomato peels or other peels was a good way of also valorizing food waste. The only aspect that we didn't like so much about these solutions is that the films were very flexible, but they weren't really stretchy. So and they weren't that easy to fabricate. I mean, yes, they could be done, but we wanted something that was a bit more of a facile fabrication method. So we tried also using cutin alone and just coating surfaces, and that worked well. But yeah, once again, we wanted to obtain something that was flexible. This is, by the way, the appearance of the films that we created. The work is described in this paper, and as you can see, they're quite nice. You know, smooth surfaces and flexible. But not stretchy. So we started thinking about oils, and we were looking at oils that could also valorize the economy of Ontario. So we wanted to think about, for instance, linseed oil, and then we also tried soybean oil. These are the two main ones that we work with. We started thinking about spray-on films. Initially, this seemed to be an attractive option because we said, you know, if you don't need to prefabricate these films in the lab, you can just add components in a pretty simple way. Then the farmers have the opportunity of trying these materials out without necessarily having a fabrication facility. So that may speed up implementation. So we started combining oleic acid, linseed oil, calcium compounds as hardeners, and we produced this liquid, which we then applied on the farms. The only issue with that is, which seemed to be a good idea, is that when you apply it directly to like a haystack, or in this case, like a model, we went to a farm and we tried this. The farmers and we noticed that there was some penetration in between the layers, and so sometimes you would have holes, pretty much, right? So to offset this, you can put some sort of like material on the bottom and then spray it on top. We tried this at a garlic farm for mulch, but it seemed like this was not maybe the most facile way to apply the material. The farmers seemed to express an interest in having prefabricated films. And so what we did is we went back to the same places. As an example, this is the same garlic farm where we did this trial. We pretty much went back and we repeated it. And in this case, though, we had made these films in the lab up front. So we just took paper towels. You can take recycled paper, fabric, paper towels, any material. We pre-sprayed it with our formulation. We let it dry overnight. And then the next day we drove to the farm and applied it. And the lady seemed quite happy. She said that there was no growth of weed, and that, you know, if you made holes in proximity of her plants, then they would grow out. So she also didn't complain about rodent attacks, which confirmed the hypothesis that when you have, you know, an off smell, even though these oils are completely benign, it's they are not so attractive to the rodents. But the complication with these materials is that, once again, they're very bendy, but they're not stretchy, so they can be applied well as mulch or as silage wraps. But if you're thinking about bales, then these materials look a little bit different from your traditional bale wrap, which is of course very stretchy. So we developed these materials. These are made with soybean oil, but you can use other oils. We just tried soybean oil and oleic acid. We treated them to epoxidize them. So we made some chemical modifications, but they still remain benign. And then we added citric acid, which you can derive from citrus fruit like lemons or oranges, but it's also produced at the commercial scale. And this material was able to transform these solutions that were liquid at first into something that was more solid. And these materials then are then cured in an oven. So they do require a little bit of heating, and they need to be fabricated only in a dedicated facility, right? I mean, we could do it in the lab, but what I mean is that if you're thinking about making these in a farm, it would be more challenging. So these would require somebody to come through and say, we're interested in producing these. Whereas if you think about these other films that I showed you before, ideally, if you have the basic components, you could really produce them at a farm and apply them, right? So pros and cons of each. But so these materials are, I think, the best ones we have so far in terms of performance, because they're also stretchy. So this is just a little bit of a schematics to show you a little bit more what happens. So you have epoxidized soybean oil, and if you add citric acid, that acts as a hardener. And the interesting thing is that you can use oleic acid to tune the hardness and the stretchiness. So it's almost like the difference between having kind of stiff plastic, then you can essentially add oleic acid and you make it stretchier and stretchier up to a point, because if you make it too stretchy, then it becomes more like, too stretchy, and it's really not hard enough, right? It becomes more like a bubble gum that's melting in the sun, so to say, right? So, but it's interesting that we can tune the stretch of these materials. So this is kind of what we have so far, but what we want to do next is possibly introduce fibers in these materials that are natural. The idea is to valorize upscale materials that are waste products or not so of such high value, and make them into something that is useful for agricultural applications. And we would also like to see if these materials, in addition to making the materials less expensive because you're using waste products, can also make them harder. So we would need to compatibilize the fibers, because if the fibers are not compatible, essentially you have a matrix with something in it that doesn't stick, so it weakens the matrix as opposed to improving its mechanical strength. So essentially this is what we want to do, and we also would like to try to see, instead of citric acid or instead of oleic acid, can we use other fatty acids, other cross-linkers that would potentially further enhance the properties of the materials. Yeah, and then the last thing that I haven't listed here is that when we went to the farm show, many people expressed interest in the pots, which I initially thought they were less hard to make compared to these stretchy materials, but people were really interested in the idea of making a pot and leaving it directly in the soil for the seedlings. So that's another aspect. Can we make foams? Can we make pots that are that can break apart on demand, and really break apart maybe sooner when you want the roots of a certain seedling to come up fast, or last longer when you want to use them for like a season where they're exposed to outdoor conditions. So the ones we made were designed to be a little bit more resistant, right? But we can certainly tune them to make them less. And so what do the users want? That's something that we're constantly gauging. Yeah, and so I think this is maybe a little bit shorter than 20 minutes, but I'm happy to take any questions if you have any.
Great, thanks, Erica. Feel free to jump in with questions in the chat function, and Chloe will make sure I get those to you, or chat or Q&A. I always forget which one to use. Fascinating. I didn't realize, and maybe it's because I've forgotten, you've told me, the implications of water use and how that is likely to be one of the key drivers in our lowering use of plastics.
I think so. I think so because right now the thing is that plastics have fairly low cost because of two reasons. One is the fact that the water, just getting the water is not very expensive, but also the water has not been really treated to the same extent that it should be treated. So essentially, what you do, as an example, when you frack, you take the water, you frack the well, you take it out, and then you put it in a well right beside it, and you close it down, right? So that's really something that will have to change. And indeed, there is a push for, as an example, reusing or using water that is saline. So reusing produced water, but that is quite challenging compared to when you use fresh water. So, and yeah, so all the hidden costs, right, that are not, and at the end, if you just don't have it, you can't use it at all, right? It comes to a point where it's not even about cost, it's like availability altogether.
Yeah. You're much too young to relate to this, maybe, but I grew up at a time when linoleum flooring was very
Yeah,
common, and it's a great product. And it's only a couple of years ago I heard that it was made from linseed oil. I thought, oh, that's
yeah,
really cool. So I
yeah,
find it fascinating now that you're looking at using linseed oil,
yeah,
and that made me think, and there could be a big that could lead to a big change in flooring because there's a lot of vinyl flooring, which is plastic. So this is
yeah.
actually a pretty common problem that's not just on farm.
I know, I
And some of the
know.
alternatives might be similar too.
Yeah, no, absolutely. And I mean, if you use linseed oil as an example, you're not only you're actively reducing CO2, right? It's a plant. So, we can really use these materials to almost offset other issues, because I'm not saying that you can phase out oil in a day. By no means. I say that. So I think that, but it's good, I think, to kind of mitigate the impacts and have alternatives that could combine together, kind of mitigate the overall impact. And linseed oil contributes to that, I think.
Yeah. One of the people that we were talking to about your work was very excited about the fact that there's a lot of plastic used beyond bale wrap. It's the very
Mhm.
visible one that needs to be flexible and have certain characteristics. But there are
Yeah.
other things like artificial insemination straws and various containers that are more of a rigid one-time use, but then you want them to biodegrade. How are you approaching that? I guess that's more like the pots.
That's more like the pot. So I think that making hard materials is less of a challenge, like has been less of a challenge. I mean, if you think about Zane, the cost is once again a little bit higher than that of plastics, but if you like, but it's much easier to maybe we those pots we made with Zane, but we put in fibers, we put in spent coffee grounds, we put in like you can even use straw itself. So you can really have a product that is like has a much bigger volume because it contains upgraded materials, so to say. And so I think that there is certainly an opportunity there, because you can leave this material on the farm. I mean, linseed oil is really, if sometimes when you buy it in the stores, you see that some only have the flammable sign, some have the skull, but the skull is just because they add, say, a solvent so that it dries faster, but that is not required. That is not required because we put in a hardening agent, as an example, in the material made with just the oils. And in the case of Zane, it doesn't really matter at all, right? And you can even use other oils, to tell you the truth. Like in the case of the pots, we just like the linseed oil because it felt like it would make them harder, but you can use other oils as well.
Hmm.
Yeah. And then you can leave them on the farm.
Yeah.
Yeah.
Between today and sometime in the future where farmers are using some new biodegradable product that you've come up with to wrap round bales, there's a lot that has to happen, not just the
Yeah.
research side of things, but then there's finding somebody who will commercially produce something new. And then you've got to think through the entire infrastructure of round balers that are out there on farms, and how does that, so it could be quite a period of time. What are your thoughts on A, commercialization, so working with a partner to commercialize it, and B, how do you get that research into practice onto farms when the product is
Mhm.
there and commercialized?
Yeah, so essentially, it's interesting that you're bringing this up, because I just yesterday I received an email from somebody from Quebec, and they were saying her like that there's small company, and they saw the research and they would be interested in in hearing more about it. So we'll connect as soon as I'm back, because I'm going to be leaving soon. But essentially that's one option. The other material that is just spray on, or that can be fabricated easily, I think that, that's more like, would the farmers be willing to buy these initial materials and try to formulate them on the farm? It's almost like it would be like a do-it-yourself kit. I think that there is a little bit of, then the question is like, would they find that inconvenient? So I think we would need to tackle the problem from two sides. I think, finding commercial partners is certainly important, but seeing also if they're open to trying different practices, because they're really handy people, in the farm. So like, I mean, they would maybe be willing to try things out. And actually the lady at the garlic farm, she she called me many times. We tried many different things together until we got to the thing she liked best. So I mean, I do think that there is a bit of a gap, especially I think that we need to start seeing the cost of plastics go up before these materials can go out at the large scale. I think we really need to make that transition, and it should be like, we're phasing out single-use plastics in grocery shops, right? Like the plastic bags, you can't have them. You can only bring your own bag, at least here in Guelph, right? So, and that has already been happening in Europe for a long time. I mean, when will these initiatives start to spread out, right? Where it's like, okay, well, now you really have to kind of recycle this plastic, or you really have to do something with it, or there's a high cost associated with collection, right? When will plastics, like, why are plastic bottles so cheap? They should have an very high value. So I think that's also when this will really, like, I think, start to fly.
I can't, I really wish I could quote the numbers, but I know my son does wrap quite a few bales, and believe me, in the last year, I wish I could quote the numbers, but the price of plastic wrap has jumped significantly.
Yeah.
What drove that, I'm not sure, but it certainly has happened. We have a good question here from Evan Chafe with Bee Farmers. Is there any concern that the product that you're adding to have an off smell to deter rodents could transfer to the product that it's protecting and then make it less appealing to the animals that you want to eat it?
Yeah, well, I actually think that, it's almost like, I don't think so, because it would be just a layer at the surface. And so, I mean, it's the same material that you put on furniture. The problem with Zane is that they really smell like tortilla chips. I mean, actually, if I hadn't become gluten intolerant, when it wasn't so severe, I actually ate patties made with experimental patties made with the Zane. They are delicious. They taste like tortilla chips. So whereas linseed oil, nobody wants to eat it. So essentially that's kind of the difference. It's not like it's not really like super intense, but it's like, at least it's not yummy, right? So yeah.
Just want to make a note that everybody hopefully saw that this is being recorded, and we will make it available on our website with all of the other Horizon Series webinars. There will be a white paper associated, like all the others, on our website. And please do continue. We still have a few moments. If you have any more questions, direct them to the Q&A. We do have another one here. Has work been done on how the materials might react or respond or change soil properties when they come into contact with fertilizers or pesticides?
Mm-hmm. I don't think they would affect the soil properties that much, because I mean, we're talking about, say, an oil. Actually, Zane, on the other hand, Zane can be hardened using a fertilizer. So because it just, as you add salts of any sort, whether they're like nitrate salts or phosphate salts, they can harden. So one initial idea that we had was like, okay, can we pretty much put the Zane down and then spray with a fertilizer, and it kind of locks it in, and then as it breaks down, it releases it a little bit at a time. And so we were able to actually do that. We were able to show that you can, like, have a crust on surfaces, and that it retains phosphorus, so it doesn't run off as quickly. But then over time, as it breaks down, you start seeing phosphorus increase. Now, the reason for which we moved away from that, which I found very intriguing at first, is that we were asked to have mulch that would last for a significant span of time. So the idea with this is that, it would break down, and then, within 1-2 months, right? Like at most, you would start seeing like the zane would fall apart in its native form, because it's corn based, right? And so that's why we went to something else. No, but they would not be like, they would not produce pollutants in contact with fertilizers. No, that's something that they wouldn't do.
So this is, I'll be clear, this is not somebody asking this in the chat. This is hypothetical. If somebody in the Q&A function said, I have $1 million, I really want to invest in this, how would you use that $1 million in the next 3 years to get to the end state where it's a product that's in use?
Well, actually, I think that I would follow 4 routes. Essentially, I would really try to tackle agricultural needs in a broader way. So I would certainly look at bale wrap as one, but I would also look at all the greenhouses, because I did go to greenhouses and there's all those foams that are also used, that are one-time use pretty much, right? Foams and pots, etc. So can we also swap those? So I would focus both on soft materials and hard materials, and I would really try to understand how much can I push performance without using toxic chemicals, because the stretchy materials, right? Yes, of course you can make them like more stretchy, more robust, etc. But I would I deliberately try to do this with as little modifications as possible, as few toxic chemicals as possible. And I would like to see how much I can push that before I need to use something else, right? Because plastics are a wonderful product. I mean, they're eternal. They stretch if you want them to stretch. And so I would really try to match those properties as much as I can. But not only for agriculture, I mean, this is for any other sector as well, right? I mean, can we do this for like food packaging? Can we do this? So I would try to really broaden the scope if I had $1 million and test it in all different applications, even though I think that, for some applications, really, you could totally swap out, just not have packaging. As an example, like shampoo, do you need to use a shampoo bottle? No, I use shampoo bars, which come in a cardboard container, right? I mean, there's also that aspect. So, I mean, how much is really necessary, and how much, because this is also a legislative problem, right? You decide that you don't have plastic bags in grocery shops. Okay, can we start saying, you can't have all these plastic bottles for your shampoo, and we use only plastic where it's needed, like in the agricultural sector. Like if we have bales, we need to wrap them. Okay, maybe that's a necessity, right? But where is it not a necessity? So that's also an important aspect. I mean, not necessarily like I'm making legislation, but I think that, it's not always technology that solves your problems. It's also doing things that don't require any technology. They just require a change of habits, and it's not like a big deal if you think about the consequences of going down the path we're going.
Good. Well, that was a great answer to a pretty philosophical, off-the-cuff question. I'm impressed. So to be clear then, to anybody who's on the call or sees the recording, Erica would be open to $1 million to pursue those paths of inquiry. So I don't see any further questions. Thank you very much, Erica. I think you're one of the things I really like about the work you're doing, A, is it's relevant, and B, you're very deliberately connecting directly with farmers and end users, which I think is key to any successful research. So thank you very much for your time. And
thank you so much.
Good luck. Have a good day, everybody.
Thank you. Have a great day. Thanks for hosting me. Bye.